All right, let's get right into it. We keep hearing that AI is hitting superhuman levels of intelligence. But what if the very tests we're using to measure that are, well, fundamentally broken? Today, we're going to dig into why getting the right answer might not be the whole story. In fact, it might not even be the most important part of the story.
This quote, this just nails the entire problem, doesn't it? The second we only care about picking option A, B, or C, we completely lose sight of whether any real thinking, any real judgment is happening behind the scenes. And that brings us to a really fascinating puzzle. We've got AI models just acing these graduate-level expert exams. The scores are incredible, but are we actually looking at true reasoning, or have we just built the world's most sophisticated test-cramming machine? To get to the bottom of this, we're going to open up a case file on a very specific benchmark for expert-level AI. It's called GPQA, and I think what we're about to uncover might just change the way you think about AI intelligence for good.
You know, on the surface, the whole idea behind a test like GPQA makes a lot of sense. You give an AI these incredibly difficult multiple-choice questions, the kind only PhD-level experts can answer. If it gets them right, hey, it must be pretty smart, right? It feels clean, it's simple, and it's an easy way to track progress.
But here's the thing. That leads to a really crucial question. What if this laser focus on just being correct is creating a massive, dangerous blind spot? What if we're so obsessed with the final answer that we're ignoring the entire process of how it got there? And as you're about to see, this isn't just some academic debate, it has very real, very tangible consequences.
And to see just how wrong this logic can go, let's take it into the classroom. Because when you apply this correct answer is everything model to educational systems, our source material points out 4 very specific risks that just pop right up.
First up is something called assessment alignment risk. But honestly, we've all seen this. Think about that student who crams just enough facts to pass the multiple-choice final, but can't explain a single concept a week later. The system rewarded a clever test-taking trick, not any deep, lasting understanding.
Next, you get what's called feedback compression. The whole rich, messy, beautiful process of learning something, of struggling with it, of having those aha moments, it gets flattened down into a single, sterile signal, right or wrong. You never learn why you were wrong, which means you never really learn how to get it right. And that leads directly to our third risk, transfer suppression. This is where knowledge gets trapped in a box. The AI, or the student, looks like a genius inside the very narrow walls of the test. But the second you ask them to apply that same knowledge to a slightly different problem in a new context, the whole thing just collapses. The knowledge isn't flexible, it's brittle.
And all of this culminates in the final risk, credentialing misclassification. A degree, a certificate. It stops meaning you're actually competent. It just means you're really good at passing a certain kind of test. And when that happens, our trust in the entire system just starts to erode.
Now, you might be thinking, okay, this sounds bad, but it's just about this one test, GPQA, right? Well, not exactly. It turns out this isn't an isolated incident. This is part of a much wider pattern in how we go about evaluating AI.
I mean, just look at this. GPQA is not a lone wolf here. A bunch of other major AI benchmarks, even ones for totally different tasks, are built on the exact same shaky foundation. They all just assume reasoning is happening based on the final answer. They completely ignore the process. They create this little illusion of intelligence by making the problem super narrow and constrained.
But what makes GPQA so uniquely concerning is how close it is to home. It's not some abstract research benchmark. Its logic is directly influencing the educational tools we're building right now. And when a flawed way of testing starts to shape how we teach our kids and how we measure their success, well, the stakes get incredibly high for every single one of us.
All right, so we spent a lot of time talking about the problem. Let's pivot. If that's the wrong way to do it, what's the right way? How do you actually build a fair test for intelligence? Luckily, the source material gives us a fantastic framework for exactly that. So what are the rules for a fair fight? First, process observability. You have to be able to see the work, right? The thinking can't be a black box. Second, persistence. The reasoning has to be robust. It can't fall apart if you just rephrase the question a little bit. Third, transfer. That skill has to be able to leave the nest and apply to new, unfamiliar problems. Fourth, attribution discipline. This one's huge. Let's just be honest with ourselves. If you only measured correctness, don't go around calling it understanding. And finally, especially for education, it needs educational alignment. The test has to reward what we actually want people to learn, not just clever hacks.
Okay, this brings us to the real climax of this whole investigation. There is one last, absolutely critical distinction we need to make, a flaw in the correct answer approach that might be the most important and the most dangerous one of all.
So on one side, you have these benchmarks like GPQA. They are obsessed with the question on the left, can the model get the right answer? But in doing so, they completely ignore the far more important question on the right. What does the model do when it doesn't know? How does it behave in the face of uncertainty? That is the core idea behind epistemic safety. And this is why that matters so much. Because a wrong answer isn't the biggest threat. A wrong answer from an AI that signals it's not sure, we can work with that. We can correct that. But a wrong answer delivered with absolute, unshakable, high-octane confidence, that is infinitely more dangerous because it's a kind of failure that masquerades as success, and it shuts down any chance for correction.
Now this chart here really puts it all side by side. Look at the GPQA benchmark on the left. Its unit of evaluation is just answer correctness. Failure is defined as a wrong answer. And what about overconfidence? It's completely invisible to the test. Now look at the Beyond Autonomy framework on the right. Here, the unit of evaluation is confidence behavior. And failure? Failure isn't just a wrong answer, it's unjustified certainty. Overconfidence isn't invisible. It's the central failure mode you're looking for. And this reveals a truly chilling paradox. A model can actually learn to get a higher score on a test like GPQA by becoming more overconfident, which makes it fundamentally less safe to use in the real world. We might be accidentally training our AI to have the one trait we should fear the most.
And so, that leaves us here, with this one final question to think about. As we continue to build these incredibly powerful systems, what should be our #1 concern? Should it be a simple mistake? Or should it be the far more insidious danger of an AI that doesn't know what it doesn't know, but acts like it knows everything?